All right, how's it going this morning? All right, so remember on Thursday, we talked about special triangles. Let me just review that. We talked about 45, 45, 90 triangles. So if you have an isosceles right triangle like this, there's two shortcuts you need to remember. The first shortcut is if you're given the length of one of the legs of this triangle, like say this was like 8, then the other leg obviously is 8, and the hypotenuse is 8 radical 2. The shortcut is you just take the leg and multiply it by radical 2 to get the hypotenuse. The second shortcut was if you have the hypotenuse of an isosceles right triangle. So say you knew that this was 8 over here. Okay, then all you're going to do is just take the hypotenuse and divide by radical 2. So this would be 8 divided by radical 2. And then you have to remember to put that into simplest radical form by getting the radical out of the denominator. We multiply by radical 2 here on the top and bottom, which gives you 8 radical 2 over 2, or 4 radical 2. Okay, so the shortcuts are, if you know the leg, you multiply by radical 2 to get the hypotenuse. If you know the hypotenuse, you divide by radical 2 to get the leg. Any questions about those? Okay, so today we're going to do kind of more of the same, but it's a different type of special right triangle. So today we're going to talk about special triangles. In particular, 30, 60, 90. Okay, 30, 60, 90 triangles. And this is referring obviously to the measures of the angles in the triangle. So, it's an interesting little fact. You can always think of a 30, 60, 90 triangle as being half of an equilateral triangle, right? A 30, 60, 90 triangle can be thought of as 1/2 of an equilateral triangle. Right? Think about it. If I have an equilateral triangle like this, and I split it right down the middle, definitely equilateral triangles have 60-degree angles, right? So this is all 60, 60, and 60. So if I take this equilateral triangle and split it right down the middle, then I'm going to end up with a 30, 60, 90 triangle. Two 30, 60, 90 triangles, right? This would be 30 and 30, and this would be 90, right? So I have two 30, 60, 90 triangles if you split an equilateral triangle in half. So this sort of gives you a little bit of insight into how we're going to find missing sides of a 30, 60, 90 triangle. And just like before, we can do it in 3 ways, okay? So given any one side of a 30, 60, 90 triangle, we can find the other 2 sides in 3 ways. So the first way, just like before, way number 1, is using the Pythagorean theorem. So like, for example, suppose I gave you a 30, 60, 90 triangle and I gave you one side length. There's a 30, 60, 90 triangle. Let's suppose I gave you this side right here was 6. Okay, and this is the 60-degree angle, and this is the 30-degree angle. Well, again, I mean, you can think of this as being half of an equilateral triangle, right? Right, so I can think of this as being half of an equilateral triangle, in which case this would be 6, and this whole thing would be 6, and it would be 3 and 3, right? So if I'm trying to find the missing side, like this side, well, if it was that side I'm looking for, it's just 3. And if it's this side I'm looking for, I can just do the Pythagorean theorem. I could say x squared plus 3 squared equals 6 squared, right? I'm just using that right triangle right there, and I know 2 out of the 3 sides, so I can just find the missing side. This would be x squared plus 9 equals 36. So x squared equals 27, and x equals the square root of 27. This can be simplified. What's the biggest perfect square that divides evenly into 27? 9, right. So this would be 9 times 3. So this would be 3 radical 3. Right? And it really wouldn't matter which of the 3 sides I was given. I could always do this method using the Pythagorean theorem. But it's kind of a lot of work. So there's an easier way, right? Way number 2, just like before, if you remember from Thursday's notes, way number 2 was using similar triangles. So I could do that this way as well, using similar triangles. Yeah.
On the one part, I'm not really sure where the 3 came from.
It's half of an equilateral triangle.
Oh,
So if this equilateral triangle is 6, 6, and 6,
yeah,
half of it will be 3 and 3, right? Okay. So the second way you can do this is just using similar triangles. So the idea is if you can come up with one 30, 60, 90 triangle, then you could always just do a proportion using that one similar triangle. So here's a fact. Every 30, 60, 90 triangle is similar to this one. One, 2, square root of 3. And again, the way that I got those side lengths is I thought of this triangle as being half of an equilateral triangle. So if that's 2, this is 2, these sides are both 1, and then I just did the Pythagorean theorem to get that length. 1 squared plus x squared equals 2 squared. So this is 1 plus x squared equals 4. X squared is 3, and x is the square root of 3. So that's where those side lengths came from. So if I have another 30, 60, 90 triangle, like suppose, so this is 60, and this is 30. Like suppose I had another one, and its short leg right here is 5, let's say. And I'm trying to find the other 2 sides. Like say this is x and this is y. Okay, I could just set up proportions. Like to find x, I could say 2 is to x as 1 is to 5, right? Hypotenuse is to hypotenuse as short leg is to short leg. And then just cross multiply, x equals 10. Yeah?
I'm sorry, can you explain that all over again?
The whole
Just the
day's
second
notes.
triangle.
Oh, this.
This one, yeah.
This is the side we're given. These are the two sides we're trying to find. That's it. The goal is, bless you, the goal is, given any one side of a 30, 60, 90 right triangle, can we find the other two sides? So in this case, I'm given this side, and I'm trying to find these two sides.
But why did you do that?
This proportion is just hypotenuse over hypotenuse equals short leg over short leg. Comparing these two triangles, this triangle right here,
Oh,
So every triangle is similar to
and
that?
yeah, sure.
oh.
Every 30, 60, 90 triangle is similar to every other 30, 60, 90 triangle. They're all the same shape, different sizes, but the same shape. Right? That's what similar means. Similar means same shape, but different sizes. And the fact is that any two similar triangles are proportional in their side lengths. So these two triangles are proportional in their side lengths. I could set up a proportion saying hypotenuse over hypotenuse equals short leg over short leg, and then I get the length of that. So if this hypotenuse is double that short leg, then this hypotenuse has to be double that short leg. That's what proportional means. Okay, and then I could set up a proportion to find y as well. I could say something like short leg over short leg equals long leg over long leg to find y. So in this case, it would be 1 is to 5 as radical 3 is to y. And then just cross multiply that, y equals 5 radical 3. Does that make sense? So that's the second way you can find missing sides of a 30, 60, 90 triangle using similar triangles. The third way is the shortcut way. And just like with isosceles right triangles, this would be the quickest way for sure. So way number 3 is using shortcuts. So here are the shortcuts. The shortcuts are the hypotenuse is always 2 times the short leg. The long leg is always the short leg times radical 3. And the short leg is the long leg divided by radical 3. Those are the shortcuts. So let's think about this. Now, we could be given any one of the 3 sides. So like, for example, if they gave us the short leg, suppose they gave us the short leg. So if this is a 30, 60, 90 triangle, and let's say they gave us the short leg is like 7. According to this first shortcut, the hypotenuse is going to be double that. This has to be 14. According to the second rule, the long leg is the short leg times radical 3. This is just going to be 7 radical 3. That's it. So this was the case where we were given the 7. What if we're given the hypotenuse? So what if we have something like this, and this is a 30, 60, 90 triangle, and we're given the hypotenuse. Let's say this hypotenuse was 20. Well, if you look at the first rule, the hypotenuse is 2 times the short leg. So if this is 20, what does the short leg have to be?
10.
10. And then once you know the short leg, second rule again, the long leg is the short leg times radical 3. This is just going to be 10 radical 3. That's it. So the only other situation is if you're given the long leg. So let's say you were given the long leg. 30, 90. This is sort of like the most complicated situation in a way. Like suppose we know the long leg is 5. Okay, that's what we're given. So if you look at the shortcuts, the third thing says the short leg is the long leg divided by radical 3. So this side is just going to be 5 divided by radical 3. But that's not a good way to leave it, right? You can't leave it irrational in the denominator. So you got to multiply by radical 3 on the top and the bottom. And this ends up being 5 radical 3 over 3. Is everybody okay with that? And then the hypotenuse is double that, right? That's the first rule. The hypotenuse is 2 times the short leg. Well, if you take 2 times 5 radical 3 over 3, it's just 10 radical 3 over 3. That's the length of the hypotenuse. Does that make sense? So those are the 3 shortcuts. If you know the short leg, you double it to get the hypotenuse, you multiply by radical 3 to get the long leg. If you know the hypotenuse, you just cut it in half to get the short leg, and then you multiply that by radical 3 to get the long leg. And if you're given the long leg, you divide by radical 3 to get the short leg, and then you double that to get the hypotenuse. So the ratio is always the same. It's always, this is double this, and this is always radical 3 times that. So sometimes they might try and throw you off by giving you a radical to begin with. Like for example, they might give you the short leg is, they might tell you that this short leg is square root of 2, or something like that. So the hypotenuse would have to be double that, 2 radical 2. You just double it. And this long leg, you take the short leg times radical 3. This is going to be radical 2 times radical 3, which is radical 6. But then you can see I still did the shortcuts. I took the short leg and I doubled it to get this. And I took the short leg and I multiplied it by radical 3 to get this. Does that make sense? So this is the bottom line, like this is what you need to know to do this stuff, for sure. I wouldn't do these problems using the Pythagorean theorem or by using similar triangles. It's way more work. This is the key. The only way to get good at these is to just practice them and do a few problems, right? Any questions about that?
Is this on the test?
Yeah, definitely. Yeah, remember, we have a test on Wednesday. So tomorrow we're doing just a review of the unit for extra credit. So there won't be a recorded lesson or a live lesson or anything like that. And if you're in class, that's all we're doing is that extra credit thing. Any questions? Okay. So the homework on Delta Math is just called special triangles, 30, 60, 90.